So what we're going to do here is use the breadboard to build a very simple circuit, which is to just turn an LED on and off, and to just light an LED. But we're also going to show the usage of a digital multimeter, or DMM. So we've already learned from the circuit review that you can't hook an LED directly to a 5-volt source or it'll burn out. And that's because the forward biased voltage of an LED is somewhere around 2 volts, 2.5 volts. And it doesn't go higher than that. Or for it to be higher than that, it has to draw way more current than it's capable of drawing. And so what we really have to do is limit the current by putting a resistor in series. And we did a little math and we said, you know, a 270, I'll say a 220 ohm resistor is probably going to be a good job. So let's do that. I'm going to take just a standard LED, a 220 ohm resistor, and put them in series, 5 volts to ground, and then check things with the multimeter. So I'm going to start with going to my kit, and remember your kit, you've got all these resistors here, and I've got this here. Everyone's are probably a little different, but these blue ones here are the 220 ohms. Red is the symbol is the stripe for 2, and you've got red, black, black, and that comes up to 220 ohms. So I'm going to take that out of here, and so I've got that resistor, and I'm going to just bend it so that the wires shape this nice U, or like this staple. And it's worth talking about the breadboard a little bit if you haven't seen these before. So each one of these rows are rows of sockets that are electrically connected. So these 5 are connected, these 5 are connected, these 5 are connected. There's no connection across that gutter between them here. And on the sides are rows of sockets that are connected vertically. So, and we've got this little symbol here to kind of show you what they intended to use for. These are power and ground, right? So the one with the red stripe along it, these are all connected together. And we'll just use that for +5. And these are all connected together, and we use that for ground. And you can do the same thing on both sides. So you'll see what I did here with mine is that I took some hookup wire and bend it around. It's not the neatest bending job, but it's not bad. And I took it from the 5-volt supply, or the 5-volt terminal on my Arduino board, and ran it over to this guy here, and then ran an additional red wire to put over here. So these two are all now, these 2 columns of sockets are now connected to a 5-volt supply. Likewise, this black wire goes around to the ground. It picks up the ground connection here on the Arduino, and then I've got a second black wire here. So these are all ground. So what I want to do is I want to take an LED and go from the 5-volt over to one of these sockets, and then from one of these sockets in the same row over to ground with the resistor. So I'll put the ground in first. So here's the wire. We'll use row 7 there. Okay, so that's half the circuit. Here's an LED from the kit. I'll set it down here so you can see it. Notice that one lead is longer than the other, and that's on purpose. The longer lead is the anode, which is the positive side if you want to be forward biased. So I'm going to also bend this a little bit and make this sort of a stand, also similar design here. And I'll put the long lead in where the resistor, into the 5-volt supply, and the short lead into a row where the resistor is. And you'll see as soon as I did that, it lit up, right? So it's worked exactly the way we thought it was. Great. Always good when that happens. Now let's check a few things. Let's find out what the forward bias voltage is. Let's find out how much current it's drawing. So to do that, we're going to use this multimeter. And so I'll take these leads out so you can take a look at it here. And everybody's is a little different, but there's a lot of commonality here. So very often there's 3 sockets on here, the common one. And then this one is used for some of the functionality, and then this one is used for some of the other functionality. And in fact, this case, it's only for the 10 amp measurements. And here are the functions here, right? So we have DC volts, which is where we'll spend most of our time, AC volts, which we won't, and ohms, that's an important one too. You can have AC current, you can check a diode, you can check continuity. Over here we have battery tests. That's kind of a feature of this particular one. I don't often see those. Here's DC current measurements here. We're going to use the DC 10 amps in this case. So here are the leads. So that we also call them the probes of a voltmeter. So on one end we have these plugs that go into the sockets on the voltmeter. So we'll put those in here. And on the other end we have these sharp points, right? And these are called the probes. And you can use the probes directly. So if I go to put it in the DC functionality, it takes a while to sort of settle down. I have to hold the probes together for it to show 0 volts. And so there it is, 0 volts. And let's say I want to know what's the forward bias voltage of the diode. And so I'll put the red probe on the anode of the diode and the black probe on the other side. And I get 1.95 volts. And just to kind of show you how that works, if I hadn't done that, in other words, if I'd gone the black probe on the plus, I still would have gotten 2 volts. It just would have been minus 2 volts, minus 1.95. Now, sometimes it's kind of a pain to hold the probe, and sometimes if you're not careful, the probe can short things out, can connect 2 things together and make bad things happen. And I've done that. So we also have these little micro clips that the probes stick into, and then they have these little spring-loaded clips on there, and they're much handier for these sort of things. So I'm going to put these guys on here. And now I'm going to redo this measurement, but in this case, I'll put the red probe, just clip it onto the lead. And I'll do the same thing here. And now I don't have to worry about how tight I'm holding it against it. And I got 1.95 volts, which I think is a pretty solid reading. So that's the forward bias voltage of that LED, 1.95 volts. And that means that the voltage drop across the resistor is probably just a little over 3 volts, right? You see it just kind of fluctuates a little bit, but I'll take it off there and just move it over to the resistor. Yeah, so it's about 3.02 volts. So we can actually calculate the current because we know the voltage. Let's get my calculator. We know the voltage across the resistor is 3.02 volts, and the resistor is rated at 220 ohms, and I get 13.7 milliamps. So let's round it up, say 14 milliamps going through that LED. Well, it'd be nice to measure that directly, right? And we can, but the thing to keep in mind is to measure current, you actually have to have the current go through the device. And notice in voltage, you don't do that. Voltage, you probe the circuit and you just touch it in a couple places and pick up a voltage. You actually, to measure current, you actually have to break the circuit and make the device, make the measurement device, the multimeter, part of it. So I'm going to turn this off and I'm going to change the sockets here because I'm going to go to the 10 amp functionality there. I'm going to rotate that around. So now I'm measuring 10 amps. And so now what I have to do is I have to break the circuit. So I'm going to lift up the resistor out of the ground, keep it on the other end. Okay, so now I've broken the circuit. And I'm going to take just a little jumper wire and put it in the ground here. And if I touch the ground wire to the resistor, the LED goes back on. So that's my circuit. But now I'm going to make this part of that. So the light went back on, but now it's going through my meter, and lo and behold, it reads 0.013, which is 13 milliamps. I thought it should be 14 milliamps. And there's a couple reasons why it's probably not the same. One of them is that it's pretty darn close. So it may just be within the measurement error of this multimeter. It's a cheap multimeter. But I think it's more likely what we're seeing is that the resistor isn't exactly 220 ohms. It's a plus or minus 5% resistor. So it could be 220 plus or minus 11 ohms. So it could be 233, 211, right? So yeah, so that, that can happen. So that's it. That's the use of a multimeter, and I think that's good enough for now. So happy Happy coding, happy circuit making.